Welcome back. Today we're going to be looking at section 7.3, our last section of this class, systems of nonlinear equations and inequalities, still with two variables. So today we're going to be basically doing what we did last section, but introducing a couple exponents to it and seeing what happens if you end up with more than one solution or more than one possibility because you've got more than one exponent. And so just like last time, we've got three possible things that could happen. We could have no solution, just like last time with parallel lines, where the two lines never intersect as far as they go. You can end up with one solution where the intersection is at a perfect tangent point, or the slope is tangent to the point that it intersects with. Or we could have two solutions where you end up with two spots where it intersects. In that case, we really need to be looking out for where does that plus or minus sign affect our square root symbol to get us a two-solution system. I think in this section we're only going to be looking at quadratics or double exponents, an exponent of degree 2, and that's what we need to worry about. But it's important to think about, if we had a long curve, there might be way more solutions possible and still possible to solve. So let's go ahead and get started. The techniques which we use are going to be almost exactly the same as last week or last video. Just might have a couple extra steps in working out the math. So the first thing it says is, will you solve this with substitution? The substitution is going to look just like last time. We need to get one of the variables by itself. I'm going to go ahead and get, let's try to get y by itself right here. I'm going to try to get that y by itself. And so doing a little bit of rewriting, I'm going to move the y over and move the 2 over. I'm going to get 3x plus 2, move the 2 over, equals a positive y. And now that I've got a positive y, I can substitute that in. So I'm going to take that equation and substitute it in where I see y into my blue equation. And I'm going to get 2x squared minus substitution, 3x plus 2 equals 0. And then we solve it just like we would have solved this any time before. Remember when we solved quadratic equations, it's going to look just like that. So the first thing I'm going to do is get it into a good form with distribution. We're going to end up with 2x squared minus 3x plus 2. Distribution minus 2 equals 0. And then we're going to do a little bit of, I'm going to do slide and divide. You can do the AC method. You can use the quadratic formula if you want to, but this is just the fastest way that I know how. So it's going to be 2 times 2 is 4. X squared minus 3x minus 4 equals 0. Then we're going to get x minus, what is that? 2 and 2? No, 4 and 1. X minus 4, x plus 1 as our factors. And then remember we slid a 2, and so we have to divide that 2 back out. And we end up with x minus 2. We've got a leftover fraction, so it's going to hop out to the front, or factor out of 2 basically. And 2x plus 1 equals 0. Awesome. And so we have two factors. I might go ahead and solve for them. So right here we got an easy factor of x equals 2. And right here we've got a little bit more difficult of a factor, but you can see it up here a little better. If you look up one step above, you can totally see what that factor was going to be. X equals negative 1/2. And you'll notice we have two x's. In the past section we only got one x. It's because we're going to end up with two solutions. And so we're going to have to break these apart into first and second, and both solutions are perfectly valid. Let's see, go up and look at an example right here. No one solution is better than the other solution. They're just two different spots where it's going to intersect. And the way we find those is in two different chunks. We're just going to plug and chug those numbers back in. And so the first one, I might do the top one since it doesn't have the squared, make our lives a little better. 3x minus y equals negative 2. We're just going to plug that x value in. So 3 times 2 minus y equals negative 2. So negative y equals 6 minus y equals negative 2. Move the y over, move the 2 over, and I'll get 8 equals y. And so our first solution, I'll go ahead and highlight it because it's kind of hard to see, it was a 2 and an 8. So we got 2, 8. We'll keep going. We got a second x value for a second solution, so I'm going to plug it into the same equation and get a different y value. The equation was 3 times negative 1/2, plug it in for the x, minus y equals negative 2. Is that right? 3x minus y equals negative, yep. Okay, so we got negative 3 over 2 minus y equals negative 2. A little bit harder. We've got, I'm going to add it over and go negative 3 over 2 plus 2 equals y. All I did there is add y here and add 2 here to both sides. So plus 2 plus y. And then 2 plus that, and get some common denominators if you want to see how to add fractions a little faster. 4 minus 3 is negative 1 over 2 equals y. Oh, that's not negative 1 over 2, that's positive 1 over 2. 4 minus 3 is positive 1. So we got ourselves a y value. Or up here we had an x value, right there. And we got our second solution of negative 1/2, comma 1/2. So it was the exact same steps as before, it just ended up having to do it twice for our two different solutions because we had 2 points where the lines intersected. We're going to keep going, and we're going to say, hey, sometimes that equation is a circle. Circles are going to require us to do it twice because circles aren't functions, they're shapes. If you notice this, you'll look at this and see, oh, there's the culprit that's making it not a function, because y squared is going to take away our plus or minus. And so we're going to have to be really careful as we solve, making sure that we're doing both sides of the equation. So here we go. Let's go ahead and get started. So I am going to, it doesn't say to do it with any type of system. That's okay. So I'm going to do it with substitution. I'm going to take this x and say x equals 3y minus 10. Yep, it's totally fine. And then I'm going to take that x and I'm going to plug it in where I see a y value, or where I see an x value. And so I'll get parentheses 3y minus 10 squared plus y squared equals 10. Cool. Now we're going to do a little regular math, a little distribution and everything. So I'm going to get, that's going to be 9y squared. Remember, FOIL, first, outer, inner, last. Anytime you square a binomial. 9y squared, that's the first two terms. Middle two terms, or outside two terms, are going to be negative 30y. Inside two terms are going to be another negative 30y. Last is going to be plus 100. So that was the FOIL step. Don't forget to about this y plus y squared right here, and then the 10 on the other side. All right, so 9y squared plus y squared is 10y squared minus 60y, combine like terms in the middle, plus 100. I might go ahead and move this 10 over, minus 10, so we're going to go plus 90 equals 0. Before I solve this, if you could go ahead and quadratic formula that, or we can make our lives a little better and divide by 10 on both sides. Get y squared minus 6y plus 9 equals 0. Way easier to solve. Now we've got y, looks like negative 3, negative 3. Y minus 3 squared equals 0. Which means that y equals, well, let's do it. Y minus 3 equals 0, which means we got a solution of y equals 3, I'll do it in red, with a multiplicity of 2. Y equals 3. Remember, we don't stop there. We got a y value. We need to solve for the x value, so we're going to plug and chug it back in. I'll plug it into the second one because it's a little easier. X minus 3 times 3 equals negative 10, which means x minus 9 equals negative 10. Add 9 to both sides. X equals negative 1. So we've got one of our solutions of negative 1 comma 3. Cool. All right, let's do one more problem because it's very similar, but it is using inequalities instead of intersections. And so what we're going to do here is we're going to graph a system of inequalities and look at where we can shade sections of it. So all we're going to do for this is graph the functions like they were normal functions. So here we've got y is greater than or equal to x squared minus 1. That looks like the normal parabola, but shifted down 1. So I might do it colors. Let's do red. Red, dot, up and over, 2 and 4, backwards 2 and 4. These are the factors of a squared function, right? 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, forever and ever. Over 3 up 9. Over 3 up 9. That comes from just memorizing and really looking at that toolkit function and how to graph it from that first day of class that we did a long time ago. A quick note though, for the solid versus dashed line that you might see on these in the textbook, because we've got inclusive, I'm drawing a solid line. If it were exclusive, I might draw a dashed line for that parabola, so I know, hey, points on this parabola aren't included. So just a quick note of that. And we've got our equation says that y is bigger than or greater than this, which means the y value is greater than all of these points. What that means is I'm going to shade any y value above the line, which is going to look like that red shaded section. All right, let's do a blue. This one's just a normal line. I need to get into y equals form, so it's a little easier to graph. And so what I'm going to do is move the y over, move the 1 over. I don't know why I like doing it. I just like getting the negatives out of there. So move the y over, and you're going to get y is less than or equal to x plus 1. That's the normal function, the normal linear function. Just shift it up 1. So it's that line right there. Maybe I'll kind of do this pretty quick. Let's find out. Yeah. All the way up to the corner, probably all the way down to the corner too. All right, that's fine. That's fine for our intersection. Draw some arrows so you know it goes on forever. And actually, that's not a good line. See right there? That's a better line because it shifted up 1. Okay, so the point of this is y is less than that line, which means it's going to be everything below that. So every blue thing below that line we're going to shade. And you'll notice in the middle there, there's a little section where both of the sections are shaded, where we've got red and blue shading. And that right there is going to be our area of interest. That is the area of solutions. Any point inside of that area, and because they both are underlined, including the lines, is a solution of that equation. So you can pick any point in that orange section there, and that would be all of the solutions. But the answer to graphing the system looks just like that, where you note that the color orange, I'll say this right here, orange is the set of x comma y solutions. All right, thank you for watching. This concludes the last section of this whole course. I would highly encourage you to go back and either read through the textbook, practice some homework exercises, practice exercises in the textbook, watch YouTube videos, watch these again, watch Khan Academy, go find some resources to study as we approach our final exam coming up in the next week. Thank you for watching, and I'll see you soon.